All right, so now we're going to talk about something called end behavior. End behavior of these polynomials. What end behavior is if you were to look at a polynomial and look at its behavior, if you were to look at the graph as x got really large or x got really small, we want to describe what the function is doing as we get towards those, endpoints there. So to just kind of start things off, I'm going to pull up good old Desmos here, and we can just kind of mess around with it. So if I were to plug in a polynomial, let's just say we have, f of x equals x squared. Okay, so if we graph x squared, what we can do is just informally describe what's happening here. So as I'm going to the right, you can see that the function is increasing. As we go to the right, the function is increasing. It's just going really high. As if we were to go to the left, if we were to look at the left side of the graph, or as x got really small, the function also increased. So we would say that this function is increasing as x gets really big, and also as x gets small, the function is increasing. It's getting bigger and bigger. So what happens here if I switch the exponent, right? So if I say x cubed, now the end behavior, again, the reason it's called end behavior is because we're looking at the ends as x gets really large. I'm going to put a coefficient here so it's a little bit wider. So what is the end behavior? What's the behavior over here? Or really just as x goes to infinity, as these numbers right here, if I were to drag my cursor this way, and if I went to infinity, what's happening to the y values? Well, the y values are just increasing a lot, right? So as x is going bigger, y is also getting bigger. The function is increasing. Now, if x starts to get smaller and smaller as I go to the left, then what's happening to the y's? Well, the y's are decreasing now. The y's are going to negative infinity, we would say. It's just going down forever. Okay, so the end behavior, if we compare x squared to x cubed, is different. X squared, again, looks like this. If I change it to x cubed, it now looks like this, right? Let's say I go to x to the fourth. There's a different polynomial. It looks a little bit different than x squared, but you can see the end behavior is still the same. Both sides are just going up, increasing. As x is getting big, so is y. As x is getting smaller, or getting really big in the negative direction, y is also increasing. It looks kind of like the same thing as x squared in terms of the ends. If we look at x to the fifth, well, that looks very similar to x cubed. So we see a pattern here. If I go x to the sixth, again, looks the same thing as x squared, looks the same thing as x to the fourth in terms of the end behaviors here. So that's one thing to note. Let's go back to x squared here. What happens if I take the leading coefficient here? I'm going to put the leading coefficient back to 1. What happens when I take the leading coefficient and I change it from positive, now I make it negative? Okay, you can probably guess what's going to happen if I make that negative. Now the graph is reflected over the x-axis, and now as x increases, what's the end behavior? As x increases, now the function is getting closer to negative infinity. It's going down, right, in both directions. So as x increases, y is going to negative infinity. It's getting really negative. And as x gets negative, or at this end over here, the function is also decreasing. So basically, the leading coefficient here, as well as what degree this polynomial is really going to determine what the end behavior is. Now, we haven't talked about, let's go back to that x cubed. So there's the end behavior of x cubed. Well, what if we change that leading number, the leading coefficient, from 1, which is what it was, to negative? You can see that it just flips. So the end behavior switches. And so there's going to be a major pattern that's happening here that we're going to write down. But one thing I want you to note too is that in this example right here, we have a cubic function. It's x cubed, right? If I add more stuff here, if I say plus x, plus 5, it's going to switch around my graph. You can see my graph is switched around here, but the end behavior never changes. The end behavior, if I took this off again, is still going up and to the left and going down and to the right, and that's my end behavior, right? That never changes. If I add in some more terms here, the end behavior is still the exact same thing. It's going up and to the left, and it's going down and to the right. So what I'm trying to get at here is that this leading term, okay, the degree, the largest exponent, as well as the leading coefficient, determines what the end behavior of these polynomials are completely. All this other stuff after it, while it's going to change the graph up, is going to be irrelevant in terms of the end behavior. Because as x gets really, really big, the only thing that's really significant is this largest term. It kind of dominates over the other terms, and that's an important concept to grasp. So again, if I had, we can do the same type of thing. If I have x squared here, no matter what I put over here, the end behavior is still going to stay the same thing. It's going up and to the right and up and to the left. No matter if I have this, or if I take some stuff off, or I go minus 8x, minus 3. Okay, maybe got to zoom out a little bit here, but it's still the same end behavior, going up to the right, up to the left. Okay, so let's go back to our notes. So this is just basically straight from the textbook, and there's some notation that we want to get used to. So the end behavior of a function's graph is the behavior of the graph as x approaches positive infinity, or just goes to the right, or negative infinity, or as x gets really large in the negative direction. And again, this is important right here. The end behavior is determined completely by a function's degree and the sign of the leading coefficient. That's basically everything. The degree of the polynomial and whatever the leading coefficient is going to completely determine the end behavior. So another thing for your notes, again, you probably have to pause this video and jot some of this stuff down. It would be good to do that. Here are the patterns that we just saw, right? So if you noticed, if I have a degree that is odd, like x cubed, x to the 5th, x to the 7th, right? And my coefficient is positive, then the end behavior is going up to the right and down and to the left. Now there is this notation that you have to, that we're going to continue to practice here, and that is this right here. This we have to talk about, right? And so we can just say, if we were just talking, we would say, oh, the function is going up and to the right. So as x gets big, the function is just increasing as well. Well, this is the formal or mathematical way to say the exact same thing. We're saying as f of x, okay, f of x, the graph is increasing or is getting closer to infinity as x is approaching infinity as well. So the way that you would say that over here, okay, that's how you would read that. You would say f of x approaches infinity as x approaches infinity. Again, that's going to take a little bit more time to wrap your brain around what is that actually saying, when it's going to be easier to just say, oh, the function's going up and to the right. I can just tell you that. it's going to take a little time to get used to that formal way to say things. So in the same way, if I'm trying to describe over here what's happening on the left side of the function, f of x is approaching negative infinity as x is approaching negative infinity. So as x is getting closer to negative infinity, the function is also decreasing or getting close to negative infinity, right? So those are the patterns that you're going to see. So if I have a odd degree, but I change the leading number to negative now, well, then it's just flipped. Now I'm going up and to the left and down and to the right, okay? Or the formal way to say things, right? You're going to have to learn that notation, okay? And then we talk about even degrees. So if I have x squared or x to the fourth, the end behavior is going to have a certain pattern. So if the leading number is positive, like 2x squared, well, then we know that the end behavior is up to the right, up to the left. How do we say that formally? Right? Same thing. As f of x approaches infinity, or f of x approaches infinity as x approaches infinity, and f of x, or the graph, approaches infinity as x approaches negative infinity. So something to write in your notes. It'll take a little bit of time with the terminology. All right, so for example, if we were to talk about this notation again, right? If I'm given a graph, right? There's a graph in front of me, and I'm talking about how am I going to write this notation down here, right? Well, we can just say out loud, well, it's going up and to the left, down and to the right. The formal way to say that is this is the graph right here. F of x is approaching what as x approaches negative infinity. The translation here is as x continues, as you go to the left, right? As you're going to the left, as x is getting bigger in the negative direction, right? As x is approaching negative infinity, what is happening to the graph? Well, the graph is increasing, right? If I plug in -1, and then I plug in -2, and then -10, and then -100, the graph is continually getting bigger and bigger and bigger. So what we put in here is, this is going to be infinity, positive infinity. So we would say f of x approaches infinity as x approaches negative infinity. And in the same way, if I look at the next one, we're going to say f of x approaches negative infinity. By the way, this would be positive. You can put that or you could leave it out. F of x approaches negative infinity as x approaches positive infinity. The translation there again as you move to the right, as x gets larger, the function is getting smaller. It's decreasing, it's getting closer to negative infinity. All right, take a moment to look at this next graph and maybe just pause the video, see if you can figure it out. All right, so end behavior here. Informally, you would say it's going up and to the left, up and to the right. Okay, formally, you're going to say f of x is approaching positive infinity as x is getting smaller, or as x approaches negative infinity. And also f of x approaches, again, positive infinity as x approaches positive infinity. All right, so I know this can be kind of overwhelming to look at all this terminology with end behavior and whatnot, but again, practice makes perfect. As you do more of these, it's going to make a lot of sense. So hang in there. So, all right, lastly, let's look at some actual examples, kind of like what we were doing in Desmos, and figure out the end behavior. So if I was looking at, and I would encourage you also to have Desmos open and to check your answers this way, or to have your graphing calculator and plug it in just so you get more fluent with the graphing calculator and can get better at those skills. But before we check our answer, if you look at part A, it says, determine the end behavior algebraically for the following polynomials. Briefly justify your reasoning. All right, so here's what you need to know, is that this first term here determines everything, right? 2x squared, this is a quadratic function. So I know that the degree is 2. In other words, it's even. It's an even degree polynomial. And the leading coefficient, is 2. In other words, it's positive. Okay, so if we go back to our chart, right, we know that we have a degree that's even and a positive coefficient. We know it's going to be like this, right? So we can kind of think about, you're going to eventually memorize these patterns for sure, but at first you might want to look back and say, all right, the degree is even, the leading number is positive. What's going to be the end behavior? Well, it's going to go up and to the left and up and to the right. So going back to that, what I always do is again, look at this, pick it apart. The degree is even, the leading number is positive, so I know my end behavior is going to go up and to the right, up and to the left. And then I want to put that formally, above. How do I write that in the formal notation? So that's going to be the graph f of x is going to approach positive infinity as x approaches negative infinity. Also, the graph for f of x is going to approach positive infinity as x approaches positive infinity. So the graph is basically increasing both ways. It's going to infinity both ways. All right, let's look at part B. Again, maybe pause this video if you feel a little bit confident. You want to give this a try. Pause it, see if you can get it. Okay, for B, all we're going to look at, again, is the dominant term here. The dominant term is x cubed. So I know my degree is 3, and the leading coefficient is 1, or positive. So it's a positive leading number, and the degree is odd. So what does that mean it's going to look like? Well, you can look back in your chart. You can also just, again, informally, we can say it's going to go up and to the right and down and to the left. You can just remember that. It's kind of like an x cubed graph, right? The end behavior is going to be like that. So once we understand that, let's put it into the formal kind of notation. So f of x, the graph is getting bigger or smaller as we go to the left. Well, it's getting smaller. This is going to indicate this little part right here. And so we're going to say this approaches negative infinity. The graph is approaching negative infinity as x approaches negative infinity. And f of x approaches positive infinity over here as x approaches positive infinity as well. Again, as you go through this process and you're thinking about these polynomials, go back to the chart. It's going to take some time to just, look it up. But as you do more and more, and check it on Desmos, check it on your graphing calculator, it's going to start to make a lot of connection, and it'll be much easier. All right, let's do one more. Pause it, try it before I show you this answer. So negative 2x to the fourth, we have a whole polynomial here. The dominant term is all I care about for end behavior. I have negative 2x to the fourth. So I know that the degree here is even. If I have an even degree, that means I know the end behaviors is going to be both going up or both going down, right? So it's going to be like this, either both going up or both going down. One of those, right? So if we look at the leading coefficient, the leading number is -2. In other words, it's negative. So out of these two options, right, which end behavior is it going to be? If my leading number is negative, it's going to be this one right here. Okay, so this one, it's not going to be going up and to the left and up and to the right. They're both going to be going down there. Right? And we can double check that, plug it into Desmos, plug it into your graphing calculator, check that and mess around with those tools because it's going to help you make those connections. So formally, how do we put this into this notation? Well, we're going to say f of x approaches -infinity for both of them because the graph is going down both ways. It's going down and to the left and down and to the right.